Welcome back to the ETSI-IQC Quantum Safe Cryptography Virtual Executive Conference. It's time now for our live Q&A session with our guest speakers. During this second and final day, we hosted two panel discussions. The first looked at the public sector perspective on quantum safe cryptography, and the second focused on the challenges of moving to quantum safe technologies. And it's this second topic that we'll be expanding on now with our live Q&A session. For the next 30 minutes or so, it's your opportunity to engage with our experts. And if you haven't already done so, then please send us your questions as soon as you can. There's a form on the website for you to use, and that will get your questions directly to us. So let's introduce our guests, and we welcome back Matt Campagna, who is Senior Principal Engineer at Amazon Web Services, AWS, who joins us from Seattle in the US. Brian Lamarkia, who's Distinguished Engineer at Microsoft, also joins us from Seattle. Panos Kampanakis, who's Product Manager at Cisco Systems, joins us from Raleigh in North Carolina. And Jared Ballou, CISO at Avast Software, joins us from Amsterdam in the Netherlands. Welcome back, all of you. Let's get right to it, as we've got a lot of questions in from viewers already. Panos, I think I'll ask this first question to you if I can, but the rest of you, please jump in as well. What institutions, data analysis do you track or develop or use in determining a timeline for the risk posed by quantum computing to traditional cryptography?
Thanks, Scott. It's always hard to predict the future, let alone predicting the future on a very complicated technical matter that's the quantum computing. So we try to track the progress that takes place in big organizations that are working on quantum computers. So, that includes Microsoft, it includes IBM, and Google and other players. So we want to see, we're tracking how they're doing in terms of progress. We are also tracking Michele Mosca's prediction report that he analyzes data from various individuals, tries to come up with a report. And also we track some scientific magazines that deal with physics and sometimes have articles related to this. We do our best tracking. We know that it's not easy for someone to call it and say 10 years or 20 years. Last time we talked to Brian, Brian said 10 to 15 years, so he must know something. We're trying to do our best, being ready for when it comes.
Excellent. Thank you, Panos. Now, another question in from one of our viewers already. Jay, I think this one might be applicable to you. Have you done an inventory of your networks, applications or services that will need to be updated to quantum safe solutions? And have you identified a strategy or timeline for getting these systems to quantum safe?
Yeah. So I think actually, I'm basing it on the experience that we've already done when I was working as CISO of KPN Telecom in the Netherlands. And first thing that we did was make an inventorization of our cryptographic assets across the company. So what do we use and why, and how important is it for our business? That's the first step. And then also understanding, what is it that we want to keep using and which things do we also need to think about transitioning. So we had a 3-part strategy. First and foremost, increase the key length of every single algorithm we use at KPN, no matter what, because that buys us time. The second thing is we actually looked for very specific places between very specific data centers where there were potential opportunities to start playing, just experimenting with quantum key distribution on points of our network. And we thought this could also be a customer use case for a future that includes hybrid solutions. And we already started experimenting with post-quantum algorithms. We actually did for a VPN solution, which we thought would be relevant also for customers, a post-quantum implementation of WireGuard. And we thought, and by the way, it's using the NISP one of the NIST round 3 candidates, and I'm very happy about that. But the point is that we're trying in this phased approach to play with what was available and then apply that as it pertains to our business. And I would encourage everyone to do the same.
Excellent, thanks very much. Now we've got a two-part question in here, and Matt, I think I'll address the first part to you. ETSI Quantum Safe Cryptography Technical Committee is going to finalise a technical specification on hybrid key agreement, which should align with NIST's most recent tacit approval of hybrid key agreement. Do you have plans to engineer hybrid key agreement schemes into your systems?
Thanks. So we are definitely working explicitly on the ETSI standard. I think it's important to keep it aligned with other standards that we see. So when we get to some standardized protocols that we can use and begin those now. So in addition to the writing of the specs, we are implementing them, testing them in the real world to make sure that they're engineered to meet the demands that we see in terms of performance and bandwidth usage. So we do see that as a vital part, that these standards are sort of at least loosely coupled so that they're consistent with each other. And we are deploying those today, both taking that hybrid model, defining specifications within the IETF for TLS 1.2 and 1.3, as well as other widely used protocols that come out of work like the inventory that J.O. was talking about, that we see that we're using. So protocols like SSH, which is widely used to configure hosts on Elastic Cloud Compute within EC2 on Amazon, to be able to have the tools ready for when we have robust standards that have been well studied and engineered, that we're ready to deploy them as quickly as possible.
Great, thanks. And there's a follow-up to this one. Brian, let's start with you. We haven't heard from you. Let's introduce you into the session. The follow-up question is, in addition to a standard, what are the other important items needed to get wide-scale adoption, such as source code or security proofs?
Well, we need all of that. We need high performant, constant time, open source, side channel resistant implementations of these algorithms that are widely available for customers to be able to pick up and use. We do need security proofs and constant work on cryptanalytic attacks on the new schemes, because we build up confidence in new algorithms by trying to attack them and failing. Some of those security proofs are part of the submissions to the NIST competition. On the implementation side, we and Matt's group and Amazon and others have been supporting the Open Quantum Safe project at the University of Waterloo, led by Michele, Mosca, and Douglas Stabila. And that's got a large variety of the round 3 algorithms, all supported through a common API in a cryptographically agile way. So all of those are important. Formally verified implementations, I think, are going to come down the road. We've done a little bit of work in that space in trying to have formally verified implementations of these algorithms. There's still, that's a work in progress, and I think you'll start to see that move generally in the future as those tools become better at formally verifying cryptographic code.
Great, thank you, Brian. Anybody else want to jump in on any comments? Panos?
One more thing I wanted to add on top of what Brian said was a hardware acceleration is also important for efficiency and scaling. So we have seen what special instruction sets have done for previous algorithms, right? And how they've helped with performance. That's important in some of our use cases for equipment that's deployed, and it aggregates a lot of traffic. I'm sure it's the same for Microsoft or Amazon or all these players that aggregate a lot of connections. So hardware acceleration is also important, I think, for deployment.
Yeah, Panos makes a very good point there. Mm-hmm. That's a very good point. It's not just going to be the software implementations, but common IP blocks for hardware and hardware implementations, especially as you're talking about constrained devices. It's going to be really important too. And we saw that with past standards that came out of NIST. We don't know exactly what instructions we would want yet, but we know that we'll want some hardware acceleration too.
Great. Now, we've got a question in here from a European telco. I'm going to edit this for brevity. Jay, I think I'll start with you for this one, if you don't mind. The question is, with the introduction of quantum key distribution and then post-quantum cryptography in telecoms networks, that might make a shift of the weakest link in security. Furthermore, the overall complexity of a system increases with this combination of classical hardware and quantum communications technology. So how do we ensure that despite all this increased complexity of the overall system, that not a single weak point gets overlooked in the chain of trust?
There's this great term in the telecom industry, and it's telecom grade. Telecom grade is kind of like the same thing as, when in security, when we talk about defense in depth, that's actually assuming that something might fail, but overall you still have like continuity of service. And to be very honest with you, considering the legacy equipment that will always be part of any telecom infrastructure, it should be the job of anything we implement in terms of new technology to have that interoperability and that robustness built in. So assume that there will be weak points. We're never going to get rid of all of them, but trying to build solutions that accommodate for some weak points, but still function in a robust way, that should be the goal of, anything we build. And that goes also for when we integrate a hybrid solution like QKD with post-quantum algorithms on top of our traditional fiber networks and our current hardware. That should be possible. And if we cannot do that and we have to re-engineer everything, it's going to be ridiculously expensive. And I don't see an incredible drive to adoption across for quantum globally. It will be then a huge disparate issue with the haves who can invest in all new equipment, and that's very small number with a whole swath of have-nots, which will always leave you with the weakest link when we talk about global communications.
Great, thanks, Jay. Any of your other guests want to jump in on that question, or should we move it along? All right, happy to move this along because we do have quite a few here. And this next question is also from a telco, another European telco. Now, it was addressed to the government panel we had earlier, but I think it's still applicable for us here. The question is, and Brian, let me ask you this first. Are governments spending too much on quantum key distribution and not enough on quantum safe cryptography?
I will certainly say I think that there should be more investment in the quantum safe cryptography space. I don't necessarily want to take funds away from hardware, from physics research, but most of our systems are not going to be able to run QKD just when you look at the physical layouts of the way in which our systems are set up. We do need quantum safe public key cryptographic algorithms to drop in. And we have a lot of work to do to make all of our existing systems and everything to come cryptographically agile and easily reconfigurable for this transition to probably first a hybrid mode of operation and then purely a post-quantum operation. I would love to see more support from governments for doing the software engineering work and the planning and the rollout of that. It's unfortunate because a lot of times that's seen simply as a tax in software development, and people don't see the upside on it. But it's absolutely critical to being able to manage this coming complex transition. So I certainly would like to see more funding and support from governments for that.
Thank you, Brian. Any other views from our other panelists, or whether we need to up the support and funding for Quantum Safe?
There's never enough funding, so what Brian said was...
Never enough. No, you're right. There's never enough funding, is there? Yeah. We always need more funding.
Exactly.
Well, Panos, let me ask you this next question, because we've just got another one in this past couple of minutes. Okay. The strongest incentives to stop using outdated algorithms on the internet have come from browser vendors flagging old algorithms as insecure or refusing to accept them altogether. Will it be the same this time, or will governments create real incentives?
Yeah, so I think that's a good point. We have seen the browsers spearheading deprecation of old algorithms in the IETF especially. So I think in the IETF world, there are groups that are very active and passionate, and one of these groups is a TLS group that has participants from browsers. So uh, having a passion to improve security is always important in order to move the industry forward. There are other groups too. The IPsecMe group for VPNs is very active. So I expect that these groups are going to push the envelope faster than others. There are other standards where, quite frankly, I haven't been seeing them move as fast as I would have liked. Uh, but I think we should also expect governments to apply pressure. We know that many governments in Europe and in the U.S. and Asia, they're tracking these efforts, right? And they have an interest to see post-quantum cryptography deployed. So, I expect that NIST is going to push the envelope with FIPS after the algorithms are standardized. I expect the cybersecurity body in the UK to do the same. So, BSI in Germany probably. So I think we have seen signals from governments trying to, to regulate and push the deployment of these algorithms. So I think it's going to be both.
Great, thanks, panelists. Anybody else seeing movement from governments to create incentives here?
I think, like the original Suite B from the NSA, which recommended migrating, or thinking about what to do about AES and then already thinking about a post-quantum future. I think you do see different national intelligence services issuing advice for how they'd like to see their vendors and their critical infrastructure migrate. So I think that's going to start from there, but it's definitely going to be a pincer movement. It's not going to be only based on government incentives. It needs to actually be from software and hardware manufacturers and the internet community, people like RIPE and Nanog. They all need to pitch in order to see this as a global implementation. So that pincer movement is going to be crucial.
Great. Brian, please.
Yeah, so in addition, one of the other areas that's going to be really important is when you have certain vertical industries that have their own security protocols that they author and maintain. They're going to need to sort of initiate the migration within that industry as well. So you can imagine within, say, an automobile industry or critical infrastructure, things like that. The government, whether or not you're talking about the United States through NIST and its standards process, or folks in Europe or around the world, they can certainly say we're going to do a migration, and people who deal with the government will then have to conform to those standards. And we can see what's going to happen inside of the IETF as the major internet software and hardware providers move. But for a lot of these vertical industries, the industries themselves are going to need to take some notice of this, and the need to move and spur the innovation and the migration within their proprietary or industry-specific standards too. So it's not just restricted to the governments and the sort of the internet hardware and software community. It's going to be those verticals as well.
Thank you, Brian. Speaking of NIST, we've got another question about NIST. Matt, this might be applicable to you. Let me see. Let me read this one out. NIST has published a draft of stateful hash-based signature schemes. What do you see as the natural areas of adoption, and what do you think the major hurdles will be for integrating this into systems today? Matt, are you able to take that one, or should I pass it over?
Sure. Happy to. The stateful hash-based signature schemes require you to essentially update the private key with every signature that you perform. So that's a new sort of engineering requirements on traditional digital signatures. I think it's applicable to, I'll say, slower moving signature applications like firmware upgrades or code signing, where you have a controlled process by which you're issuing each new signed object. I think the challenges are going to be, how does that work in a highly distributed environment like the cloud, where you're building a lot of redundancy, and coordination of state across distributed nodes is expensive and is going to slow down that process, because it's paramount in these stateful hash signature schemes that you coordinate the state, and you never sort of not advance the state and do a second signature. So I definitely see applications where the long life of the object, whether it's an automobile, a router, a satellite, where you need a long-term plan for how am I going to upgrade this software, especially for things that might sit on a shelf for 5-6 years before, between manufacturing and being unwrapped. And the first thing these things need to do is get a new firmware update. And the world changes in 5 years, and so you may not be in a world when you unwrap that product that the traditional signature schemes are still secure. So I see those as being the first sort of areas of deployment for that, and the hurdles associated with it.
Great, thank you, Matt. Panos.
So we have the same perspective with Matt. I wanted to add that we have looked at hash-based, stateful hash-based for a long time, and we're envisioning using them in for these use cases, image signing and software signing. State management issue is very important, as Matt said. Some of our chips support a limited set. I shouldn't overstate the number of chips, but a limited set of chips of ours do support it already. And we feel that, like Matt said, if it's a one signer and it signs offline, it doesn't sign live connections, we can manage state successfully, right? That's the big concern. But I think overall the industry realizes the state problem and it's reluctant to use it anywhere else. Initially, we were even thinking that stateful hash-based could be used in a root CA environment where the CA signs something and goes offline, right? So we thought that that's safe enough. But I think the industry disagrees with me on this, and because if a third party is signing for you, you can't be sure that state has been managed properly. So I believe that the best use case is the one that Matt identified, and the industry that's why it's going to use it for, nothing else. And definitely we're planning to use it ourselves at Cisco.
Thank you, Panos. Now we have quite a short question in. I'll put it out to all of you in case any of you want to answer this one. Wide-scale adoption of QKD seems to require satellite to ground connections. Are any of the panelists tracking any of the developments in this space?
We wrote a paper with the European Space Agency to try to figure out which use cases would be applicable in order to actually justify a satellite to ground QKD link, and in what telecom and critical infrastructure and banking use cases you could figure out where this would actually be a requirement to provide secure communications. So yeah, there are very specific, there's not a lot, but there are very specific use cases.
Thanks. And Matt, go ahead.
I'll follow up. I mean, we have looked at what's available today, sort of following along the lines of Jaya, who spoke about the inventory. When we look at the AWS infrastructure, we do have a service called Ground Station, which is the downlink for satellites that can then connect to our ground stations and get their data directly from their satellites into their AWS environment. And so it does, we have parts of those pieces that align to a space to ground QKD solution. So we did look at the state of the art there. We found that Spectral has the Spooky satellite, which at this point is, my understanding, it's a quantum QKD source. It doesn't transmit. They're just measuring, its ability to sort of operate in I believe it's a LEO orbit, but I'm not 100% sure of the orbit. And they are progressing that, doing experiments, going to get to a ground space to ground QKD connection where the quantum source is in space and communicating down to the ground. And then by contrast, I think the Canadian Space Agency is, we heard last year that they are at the ETSI conference, that they have sort of the opposite configuration that they're experimenting with. I don't think it's launched yet, but so I haven't been tracking it very carefully, but they have a ground source QKD to a satellite experiment that they're launching. So at this point, at least commercially, outside of what China has done, there's really just experiments. It hasn't matured to the point of that I've seen a commercial QKD source for satellite.
Great, thank you, Matt. And I think we've got probably time for one more question. Brian, let me try and ask this one of you first. The question is, let's consider large public infrastructures. Experience shows that changes of algorithms often take 10 years or more. Do you think we need more flexibility in the design of infrastructures to cope with the more rapid changes in cryptographic algorithms?
Yes, absolutely we do. And the questioner's point is very well taken. When you look at critical infrastructure systems, you may only have an opportunity to update them on, say, every 15 years or so, possibly even longer. And so part of the advice that I give to customers that come in and talk to us right now, or governments that come in, whether they're industry customers, government customers, is that if you're in the process of putting out a request for proposals or a design process or an architecture process for a piece of critical infrastructure, even though our deployments of post-quantum cryptography may be a number of years off, you have to start building those requirements in now, and you have to make sure that you are at least designing today and architecting and putting requirements in place to those systems so that they can be more easily reconfigured. The fact of the matter is, all cryptographic algorithms will eventually weaken and fail over time based on what we learn from cryptanalysis, or as an attacker's assumed compute power gets better, or as we develop computers based on quantum physics. And so you have to have this configuration capability built in, because at any point in time you may want or need to change what algorithm you're based on. And we haven't really done a great job of that as an industry, or as constructors of critical infrastructure. And so I absolutely believe that that's an important point. And anybody who's looking at designing some new system now, or something that's about to go out for bid, absolutely ask the question, how are you going to deal with the transition to post-quantum cryptography? Because we shouldn't be deploying anything that doesn't at least have a roadmap for how to deal with that at this time.
Yeah. Great, thank you very much, Brian. Anybody else want to jump in? Last chance to comment on one of our questions before we wrap things up. In that case, I think we should bring our discussion to an end, because we've hit our 30-minute mark. So that, unfortunately, is all the time we have. We need to wrap up the discussion for today. A big thank you to all of our guests, and also to those viewers who sent in their questions. Much appreciated. So that closes the ETSI-IQC Quantum Safe Cryptography Virtual Executive Conference for this year. All of our content from both days is being made available to view on demand, including this final session. Thank you to everyone involved in this event for working so hard to make it happen. Please stay safe, and until we can meet again in person, goodbye.